Hi, I'm Heather.
And this is Jax.
Welcome to Ask AI. Ask AI is a podcast dedicated to artificial intelligence. Finding out what artificial intelligence even means. We're going to learn as we go.
Let's talk AI.
We are super excited to have Kathryn Hume with us on our first episode ever of Ask AI. She's the VP Product Strategy at Integratea, Venture Partner at ffVC, and generally one of the best people that I've ever heard discuss artificial intelligence. So without further ado, Kathryn, in your own words, could you tell us what is AI?
This is just a tiny little question here.
It's
you
really
want to start
small.
off with? Yeah. So there's some psychologically helpful definitions, and then there's some more rigorously technical definitions. So I do like to think of AI as whatever computers can't do until they can, which was something that I inherited from my former colleague and boss, Hilary Mason from Fast Forward Labs. And what I like about that definition is it shows how ambiguous the term is, and it also situates it as something psychological as opposed to technical. So our perception of what seems like a boring standard task for a computer. I like to give the example of Google Maps as something that is powered by machine learning but seems like it's plain old technology and not AI, is different from that of, let's say, autonomous vehicles that seem like they're just barely possible, so they feel very AI-y to us at the moment. But the field has been around for a long time. It started in the 1950s, and it's evolved, and there's been different types of technical strategies underlying the capabilities over the years. But for the last, I'd say, 5 years or so, it's primarily been machine learning. And I'm happy to dive into the various types.
That would be wonderful.
Cool. So the basics of machine learning, I like to start in thinking about there's differences between what we call supervised learning and unsupervised learning. So supervised learning is the techniques that power most products on the market today. Although when you hear about machine learning first in the media, you read about it as machines' ability to find interesting patterns in data. And it feels like they find those patterns without having any direction from humans. They're just sort of super intelligent machines that can go through and discern stuff that we normally wouldn't be able to discern. So that is actually what we call unsupervised learning, which is unguided, and it's using techniques to mine out information and data. And while very practical for exploring a data set, they tend not to be the techniques that are powering most products. So the techniques that are what we call supervised learning, which is basically, I like to think of it as the inverse of high school algebra. So, and underlying all of this is math. So when we're in high school, we're given problems. If you think about a line, y equals mx plus b, to go back to the horrors of when we were in high school.
I was a
having to do this
mathlete,
stuff.
so this is actually like really positive memories.
Awesome. Yeah. So
I'm kind of run away.
I used to teach law school, and it was like we left math. We chose law so that we could get away from math. Like, why are you bringing this back? But in high school, we're given normally m. We're given B, and then we'll be given an X, and they're like, solve for Y. With machine learning, we're given a bunch of X's and Y's, so we're given a bunch of the right answer multiple times, and our task is to solve for M. So we're supposed to, what we call learn, which is a technical term in the field, a function that does a good job representing the patterns that tend to show up in that data. And when it's supervised, we start off again with a lot of those Y's. So we know the right answer in advance and just sort of shift around our functions to do that. So that seems pretty abstract, but if we bring it down to earth in terms of practical things, it can be used to do something like predict housing prices. So it's pretty hard as a layman to go out and discern, look across the real estate market and figure out how much we should put our house on the market for. But it's pretty easy for us to measure how big our apartment is. We can go to Home Depot or whatever, I'm American, whatever the equivalent is here in Canada, and we can buy a tape measure, and we can just like measure our house and count. And we like to do things like that. And if we find that there's a tight correlation between the size of our house and how much our house costs, and we go around and we ask our friends how large their house is and how much it costs, we plot a lot of those data points, we can use that to make educated guesses about how much we should put our house on the market for. And that's the essence of machine learning.
We still do have Home Depot up here. It's not just igloos and dog sleds.
But she would go to Canadian Tire.
Canadian Tire. I go to Canadian Tire. That's right. I should
Oh,
have
if you want to represent the country.
Learning so much more about the country as we do the podcast. Yeah. So that's a pretty simple example. With deep learning, whereas as opposed to going from this simple old M, we can take M, explode it out into 500 dimensions, which we humans with our measly human brains that only exist in 3 dimensions and time, have a hard time perceiving. And we can describe functions where M is incredibly complex, right? It's got millions of parameters, and use that to figure out functions that do a better job on more sophisticated data, like images, like videos, like text, right? So the big breakthroughs that have been occurring over the past years is we've gone from, I think I can predict my house from its size, to I think I can label that this picture has a cat in it, or this is a glass of wine, or this is indeed a video with an abstract caption, right? We can do similar, at their essence, similar tasks, just much more complicated. And then if we shift into reinforcement learning, slightly different paradigm where we're trying to figure out how to optimize a set of processes to make the best decision over time. So we set a policy that guides the way in which our functions try to figure out what they should do next to optimize against some task. And then we learn that policy based upon our performance against the goal. So it's useful for a slightly different set of applications than perceiving things. It's more the techniques that are promising for areas of robotics. So how should an object move through space to achieve some goal? It's used often in the often cited examples of AlphaGo, so in games, where we say the objective of this task is to win the game. And then you think about, all right, first I'll make this move, and then the opponent makes a move, and then you make the next move. But guiding that is the central policy that then is optimizing each individual step so as to achieve the task in the game. Reinforcement learning is the fiddliest and the sort of most researchy of the fields. It's not really in a lot of commercial applications, but it's also the most exciting because it's the one that maps the most to what's most meaningful for us in life, right? Making decisions, figuring out what the best choice to make is when we're like, should I take this job or should I take that job? Should I fall in love with this woman or should I fall in love with that woman or this man or that man, depending on what your gender and sexual preference is, right? So I find the sub-questions in reinforcement learning to be absolutely fascinating, but it's still sort of very early in its commercial use.
Thank you so much for that really great overview of all those different areas. There's a lot of talk about AI. There's a lot of news about AI, and there's a lot of misconceptions, I feel like, about the field and the technology. If you could dispel one misconception or something that you think a lot of people have difficulty understanding about artificial intelligence today, what would that be?
Oh gosh, there are so many. So I wanted to mention at least 2. One would be regarding the future of work. So there's a lot of fear that the machines are getting so smart that they're basically going to put us poor people out of jobs within the next 5 to 10 years. And while there's certain subtasks of work that machine learning can be used to help automate, it seems, in my experience working with enterprise, that we're pretty far away from having this be sort of massive job loss and meriting discussions around universal basic income and the like. So in my mind today, AI is more like an idiot savant than a Renaissance man. So it can do things, sometimes tasks, however, that seem really difficult to us. So things like radiology, so diagnosing whether or not a lung is cancerous, or accounting type work, or even paralegal work, so discerning whether or not a document is relevant for a case. There's all sorts of stuff that requires professional degrees, but actually if you dissect the type of work that's done, it's pretty narrow in its scope. So those are the things that AI excels at. The systems are really bad at creative thought, synthetic thought, doing two slightly different things, like buttering toast and tying one's shoes. That's super hard stuff that won't happen anytime soon. The second is that the biggest risk in AI is existential threat to humanity, where it's akin. It's like the same coin, different side, I would say, where these systems, since they're optimizing their intelligence, they very quickly will become so smart that they realize the best thing to do is just kill us off so that they can live in peaceful serenity in their machine worlds, which is hyperbole, but some sort of threat of superintelligence. Those aren't the biggest risks. The biggest risks are that these systems are what I like to consider convex mirrors of the existing evils in society today. And if we focus our attention on issues around bias and explainability and more practical and ethical issues, I think we'll be fighting a better fight.
perfect segue. The notion of explainability is definitely a challenge in the field, and I've just really always wanted to ask someone to explain explainability. That's now. Kathryn, can you explain what you mean by explainability?
This is a totally legit question because it's a term that's still really ambiguous in the field. So there's what we think it would mean to explain something as we talk to one another in our day-to-day world, and then there's how a data scientist or a machine learning scientist interprets this question when they're building out mathematical models, and even machine learning scientists consider this word differently. So the layman's let's say not the layman's understanding, but the understanding across the community today is that it's a term that refers to our ability to explain why a model makes a prediction like it does. So, for example, going back to our real estate example, that we build a system and we say, "Dear system, tell us how much we should put our house on the market for," and it says, it does its background computations, and it outputs, I think it should be $1 million, and I think that with 78% confidence. So you say, well, gosh, machine, why do you think that? Right? So it's effectively the question of our asking why a prediction is made that's at the heart of explainability. And the reason this is interesting, there's a couple of reasons why it's interesting. The first is, if we go back to the difference between deep learning and machine learning, once you get up to the deep learning realm, as mentioned, we go from 2-dimensional space to 500-dimensional space. And all of the knowledge that the system learns from the data is not constructed and shaped in a way that is sort of linear. It's distributed across this, what we call a neural network, which is various nodes of computing that have weights between them that are connected to one another. And basically, as opposed to having the why be centered in one focal point where we could look in and ask questions of it, it really is distributed across this network and lies within the probabilities that exist between these weights. So it's uninterpretable, right? It's very hard to interrogate. So it's a challenge because it's almost like doing a deal with the devil, where we, in exchange for the great power and the great accuracy and the great just ability and capabilities of these systems, we're exchanging our ability to know exactly what input feature in our data is leading to the output.
So you've had a really interesting career path to date. You started off with mathematics for your undergrad. You then transitioned to achieving a PhD in comparative literature from Stanford. And since then, you've honestly become an authority on the intersection of technology, ethics, law, and society. So knowing that some of our listeners might be really new to trying to learn about AI, could you tell us a little bit about how you approach learning about the field and thinking about it, although you've obviously been involved for a much longer time?
It's a great question. So it has been useful for me to have had the mathematics undergrad because a lot of, as we've discussed throughout this podcast, a lot of what's under the hood in AI is just math. It's just a bunch of you put numbers in a chart and then you do stuff with them. And this is somehow leads to these amazing capabilities, which is so cool. I think it's worthwhile to start with my interest in the field in the first place, which came from when I was at Stanford, and I took an internship working for an online advertising company that, as part of its targeting strategies, did semantic targeting, which is basically somebody comes onto a site and say they're reading about, I don't know, airplanes or whatever, pick your topic, trees. And then there are these systems that can say, oh, Kathryn's interested in trees. Let's show her an ad for clippers, or going back to Canadian Tire for Canadian Tire because she loves those little brochures, which are actually pretty cool and really cool design.
Yes.
Yeah, exactly. So let's show her some clippers because she likes trees. So when I was keen to understand how that worked. And when I went and talked to the partners for our company to ask them questions about it and looked into the technology, I was very shocked to find that they weren't viewing language the way we view language. So there was no notion of meaning, syntax and semantics. There was no notion of the way in which words were ordered in a sentence to create grammatical sense. It was just, these two characters are next to one another with a given statistical frequency, or these two words are next to one another, which is what we call sort of an n-gram classifier. And I just found it dumbfounding that that basically just viewing language as a set of statistical patterns could lead to the perception that there was real meaning behind the systems. And so I took a couple of jobs working actually for law firms, which got me deep into the realm of ethics and law. And at the back of my mind, however, was consistently curious about this amazing capability to model language, but within a mathematical space. And eventually that led me to my last role in New York City, and I worked for an applied AI research lab and just sort of got deep into the various sub-techniques, and also worked with enterprises and learned a lot about the challenges of applying things in practice.
Totally. So if you could list a couple right now for our listeners of your favorite resources that you kind of look at to find like good news or interesting insights, I think they'd be keen to hear from you.
So there's a lot of great newsletters in this space. My friend Rob May has one called Inside AI that has a great sort of weekly reading list. There's one by Azim Azhar, I think his last name is, out of the UK, The Exponential View, that comes out on Sundays that's a little bit more policy oriented. There is the O'Reilly Media has an excellent selection of things that dig a little bit more technical. They sort of have a range from business down to I really want to learn how to build a data product, depending on what one's interest is. There's, of course, the great content that comes out of Integrate.ai, where I work, and then also Nudge.ai, where Jaxson works, we just try to really not be pushing product onto people, but try to help them understand the space. I'm a regular reader of Jack Clark's newsletter. He works at OpenAI, so I think if you go there and subscribe to his, it's great. The Distill blog, there's a couple of folks that are working on long-form content where you can really dig in, and you need to be patient, like devote a couple of hours to getting through stuff, but they break down the really sort of abstract math in the research community into something that's A, beautiful. So often the demos that they build are just visually stunning, and B, they really just have focused a lot on communicating things in plain language.
Awesome.
Kathryn, I almost thought you said Aziz Ansari there for a second as the master of AI, one of those first resources you mentioned.
It's a master of none.
Oh, well. Kathryn, you are one of the rare people who, quote unquote, made it in New York City, but then chose to leave, which I think is really, really interesting. And now you're here with us in Toronto. Joined Integrate.ai. I would say one of the most exciting startups in AI that we've seen this year.
Sure hope so. Yeah.
Sure hope so. I can affirm it. You guys have been in the news constantly, but I'm wondering, tell us what's really going on. What's the story there, and what are you guys working on?
At Integrate, yeah. So we are building out a platform that helps large consumer enterprises. So we work with banks and insurance companies and Canadian Tires of the world, and not yet, but hopefully, and media companies, et cetera. So large companies that touch a vast consumer bases, and we help them apply AI to generate more meaningful experiences for their customer. And the uniqueness of our approach is we're not a bunch of consultants who come in and take data and build models and hope that it works and leads to more money for companies. We're building out a platform where there can be exchange between different businesses who could benefit from having a more broad insight into what their customers are doing. And I can say that that brings with it excitement, but also a whole host of challenges because companies aren't used to sharing data. And so we're doing a big bet on Canada's winning the AI race by enabling enterprises to collaborate with one another more effectively.
And why did you decide to leave New York City? And maybe you can talk more about why you think Canada, or Toronto in particular, is well placed to win that AI race.
Sure. So my primary reason for being here was that I really felt confidence, trust, and admiration for the founder of my company, Steve Irvin. I met him about a year ago and was introduced via Georgian Partners, which is a pretty rad VC firm based here. They normally do Series B, but they made this anomalous investment of $5 million seed into Steve. And I was like, well, that's curious. And then I met Steve and I was like, oh yeah, I get it. This guy's awesome. So his vision, his charisma, and then also our ability to collaborate was really the first reason. And then I'd heard a lot about the Vector Institute, the sort of like holy trinity of Jeffrey Hinton, Yoshua Bengio, and Rich Sutton. And I was like so drawn to the ability to get to know them and work with them here in Canada. And it's been marvelous building friendships with just my heroes in the field. And then the third thing is I actually feel I lived in San Francisco before New York. I feel like we're at the beginning of something special in this city, and I genuinely believe that. It feels like it's at the cusp of transitioning from a pretty cool tech town that has a couple of startups to like a powerhouse that can really shape the future of the tech economy, and it's exciting to help build that.
It does seem like there's hundreds of startups now and communities working on AI, and given that you work with larger companies and organizations, I'm wondering, they obviously seem keen to jump on this AI boat as well.
Yeah, large enterprises, yeah.
What do you think they're particularly struggling with, and governments are going to be struggling with to adopt AI into their operations?
Well, I mean, the foundations are technical, so having enough data to really train the systems, and then having the agility to sort of shift around how they're thinking about work and business processes to adapt and automate where AI can be helpful. I think that's the hard part, but almost the easy part. The bigger questions are around fair use of data, so revisiting data privacy assumptions. So just today, it really crystallized for me that machine learning products shift around the rules of the way for us that it's best for us to protect data. So historically, we've sought that minimum use, right? You want to share data as little as possible and to expose it to lower amounts of risk. In the machine learning world, it's actually better to have more data for multiple reasons. So the first is in the world of privacy, when hacks occur at the level of a model as opposed to the level of individual data, if you've got more data, your model would be more accurate, and actually individual data will be more safe because it will be harder to find the needle in the haystack as opposed to having one person's data sort of contribute to the model as a whole. And the second is that for us to fight these battles and ensure that we're not just replicating existing social biases, but setting policies and designing algorithms to hopefully render society a little bit more equal, companies like ours need access to sensitive data, to people's gender, their ethnicity, their race, et cetera, in order to solve those problems effectively and not use proxies. And so we need to sort of shift around our thinking on the best way to work with sensitive information to solve this problem.
Great. And one of the things I think is really interesting about you, Kathryn, is that you're both simultaneously an operator and executive of a business, but you're also working on the investment side as a partner. I know you're a venture partner at Fast Forward VC, a seed and early stage technology venture capital company.
Founder-friendly VC.
Founder-friendly
yeah,
VC.
I have like
I'm going to say that
FF.
again.
Yeah.
So I know you're also a venture partner at Founder-friendly VC, a seed and early stage technology venture capital firm. So as someone who both is working in this field and who's sourcing deals, I'm wondering if you have any advice for current aspiring AI entrepreneurs and what, anybody who's listening, what they can do better.
Yeah, it's a great question. The first is try not to do as many things as I do. It's really great to be focused. It can be hard to...
Role modeling 101.
It can be hard to... Yeah, it's like I'm trying to work on essentialism and prioritizing things. My colleague Jason Silver is like the best at that. And I'm always like, man, I got to say no more often.
Jason's your COO,
Thanks for saying
right?
yes to being on the podcast. We appreciate
absolutely.
it.
This is great. Yeah. So I think... for me, it always goes back to when you're building a company, and this is, I focus on early stage companies, and I'm passionate about early commercialization. It's just accepting that there's such a long slog between having a great idea and realizing the commercial potential of that idea. And so one has to love the work. One has to love one's colleagues. The thing that I've seen since I've been a partner, the greatest risk to early startups is that the founding team doesn't get along with one another. Like it really is that. It's less, there's trying to find product market fit, and there's like fiddling around with the tech and solving hard problems, but it really ultimately comes down to people being able to work with one another. So I think finding founders that you trust and love in a collegial way is really important. And then I think not falling into the hype. I mean, it's so horrible to see so many companies rebranding themselves as .ai and like having that describe something that's not under the hood actually artificial intelligence. It's confusing buyers. It is so risky because it leads, if once people realize that this isn't as promising and exciting as they thought, as they get down to the real practical work of applying things, it can lead to disappointment that can then have ripple effects across the ecosystem. So I think it's not that we should all be boring and reveal that this takes hard work on the back end. There's a wonderful balance between excitement and like practical work. But I think just the nitty-gritty reality of building companies needs to be kept in mind to make us all successful.
Are there any patterns or practices that you think you're already developing in Integrate.ai that have helped you be successful so far?
Yeah, so I think there's a couple of things around A, the tech, and then B, just the culture and style. So accountability is huge for us. And we don't always get it right? Sometimes we think we know that somebody's in charge and responsible of something, and then, a couple of weeks go by and it's like, who's owning this? Somebody needs to be responsible for this outcome. And the minute one person owns it and can drive, it's like magic happens. So it's super important to be clear on that. And it's amazing how, in our company, we grew relatively fast. So we went from 1 to 25 in less than a year. And it's hard to find accountability in a company of 5 to 10, and it gets really hard really fast as you scale quickly. So I think that's super important, but I feel like we are really mindful of that and putting in the right gears to be successful. The other thing is empathy for buyers. So there's often rifts between technical teams, well, even go in machine learning, science teams who are interested in sort of exploring experiments, engineering teams who want to build stuff fast, sales teams who want to solve customer problems or potentially get overexcited about what technology can do, and the engineering team are like, you sold what? And like this happens in every company. And I think having empathy across those groups, and then also having empathy for what a customer really experiences, and the fact that like people working in enterprises, no one's stupid. They are dealing with a different set of challenges that we in startups deal with. And I've seen a lot of hubris on startup sides where they feel like people who work in enterprise just aren't at their level, they're not as interesting. And that's not the way to be a great business, and it's also not the way to win customers.
So your bio says that you speak 7 languages. So I'm wondering if you could say thanks for listening to the first AI podcast in something that's not English.
I'm going to say it in French because we're in Canada.
Right after the first Ask AI podcast.
Yeah,
the first Ask AI podcast. Yeah. True. Can you say thanks for listening to the first Ask AI podcast in another language that's not English?
All right. So since we're in Canada, I'm going to say it in French. Merci d'avoir écouté la première podcast de Ask AI.
Merci.
Do it in.
What are the 7 languages that you speak?
French, Spanish, Italian, German, Latin, Greek, and I'm learning Mandarin. So I cheat a little bit with the learning Mandarin.
I'm learning Mandarin too, but not quickly enough. Thank you. Merci.
Merci beaucoup.
It was great to have you. Thank you so much for joining us, Kathryn.
Thanks so much for joining us today. This was so much fun.
It's a total pleasure to have you here.
And the other thing about being in Toronto, I love you too. I really.
Aww.
It's just been so.
Kathryn.
Thank you.
I mean that. It's been the friends that I've made here have been absolutely fantastic. So I think it's the most important thing I've learned since coming to Toronto.
Well, à bientôt then.
This community is great.
This episode was co-produced by Robin Edgar and Mike Letourneau. The executive producer was Chris McClellan. Ask AI includes this podcast, a helpful chatbot, and live events. For more information, please visit our website at askai.org. Do you have questions about artificial intelligence and workplace automation? We'd love to help answer them. Send your queries to podcast@askai.org or tweet to askai.org.